Welcome back. Today we are going to talk about Kube Proxy and how exactly Kube Proxy help in routing all the traffic for services in Kubernetes. Little bit about the Kube Proxy. Kube Proxy can run in various mode like IP table, that is the default mode. Then we have the kernel space mode. Then we have the IPVS mode. IPVS mode is kind of advanced mode and the default mode is IP table. So in this video, we are going to understand what the service is. Then we will move to the endpoint, and after that we are going to understand the Kube Proxy. And in the last, we are also going to do a demo so that we can understand Kube Proxy. First, understand the Kubernetes architecture. In Kubernetes, as we know, we have the master and the worker node. Master, we can also say the control plane. So let me create this thing. So this is the cluster, and in the cluster we have the master and the worker node. Worker node can be 1, 2, 3 depending on the requirement. So this is the master node. Sometime we called this one as the control panel as well. And in the master node, we have services like etcd. I'm not going to explain these services. For that, I'm going to create a different video. Kube API, then we have the Kube scheduler, and we have the controller. So these are the services which are running on the master. Now, when it comes to the worker node, on the worker node, we have 3 services running. First is the kubelet, second one is the Kube Proxy, and the third one is the container runtime. So these 3 services running on the worker node, and on the master node, we have these services running. And in this, we are only going to focus about the Kube Proxy. Now we understood where the Kube Proxy run. But now we need to understand what exactly the requirement for the Kube Proxy. Let me delete this thing. As we know, ports are ephemeral in Kubernetes. So they can be terminated or restarted at any time, due to which we cannot rely on their IP address. So what I mean here is, let's suppose I have a worker node, and inside the worker node I have one of the pod, and inside the pod I have one of the container, and this is the container where I have my application running. Now let's suppose there is a user, okay, and this user is trying to connect to this pod. Now if this pod is ephemeral, it can be terminated, it can be restarted any time. And when it is going to restart, what will happen? A new pod is going to be created. And when the new pod is going to be created, what will happen? This pod has its own identity, like it has a different IP address than this. Now this pod, and where I have a container, and inside the container I have my application. So it's very difficult for the user if pods are keep on restarting because their IP address are not fixed. Now, in order to overcome this thing, we have the service. So this is the service. Now in the service, there is a mapping of the pod, and rather than connecting directly to the pod, what the users are going to do is, users are going to connect to the server, and this service is connected with the backend pods. So it might be 1, 2, 3, 4, whatever it is. So this service is connected to the pod. Okay, fine. Till this point, we are able to understand, okay, we cannot directly connect to the pod as they are ephemeral. If they are going to restart, their IP get changed. We can use the service in between, and service is responsible to connect to these pods. But now the question arises, how the service will get to know when there is a pod restart or when there is a new pod created? In that case, we have the Kube Proxy. So let me go back to so this is the Kubernetes cluster, and inside the Kubernetes cluster, we have the worker node, and on each worker node, we have the Kube Proxy running. Now this Kube Proxy is responsible to update the service. So how exactly this thing is? Let's suppose this is the cluster, and this is the master node, and this is the worker node, and inside this we have a pod running, and this is where we have the service. Now this service is connected to all the 3 pods. Whenever the pod restart or it IP change, Kube Proxy is going to update this thing to service. This is my service, and this is the pod. So this is the work of what? Kube Proxy. So Kube Proxy work is to monitor the changes and update accordingly. Let's look at the demo so that we can understand this thing better. Now here I have 2 files. Let me do ls. So one with the name deployment.yaml, and the other one is with the name service.yaml. Nginx.yaml we are not going to use for this demo. So let me open this deployment.yaml and let me explain this file to you. So here we have the API version, then we have the kind as a deployment, and this is the name of the deployment. Now here we have replica 3. So let me do one thing, nano, and let me change the replica to 1. And after that, we have the selector, that is the match label as app nginx. This is very important. Then we have the template. Then the specification. This is the container information, and it is using the container port 80. And this is the image, and this image is coming from the Docker Hub. Let me save this thing. Let me also open the service.yaml, deployment, and cat service.yaml. Now this service, if you see, we have the specification app nginx. So this service is going to connect to all the pod deployment which contain this specification. So here if we see, we have the same specification here, app nginx, app nginx. After that, we have the type as a node port, protocol TCP, port is 80, target port is 80, and node port. Now here, if we are not going to define the node port, it is going to pick up any random number above 3000. And this is the name, and this is the name of the service. So let's deploy both the thing. kubectl apply -f deployment, and kubectl apply -f service.yaml. Now let me go and check for the pod. kubectl get pod. Now here we have one of the pod which is not in the running state. Let me refresh. Yes, now it is in the running state. Nginx deployment, this is in the running state at the moment. Let me do one thing. kubectl get pod -o white. With this option, I will get the IP address as well for this pod. Now let's check in the Kube proxy whether we have the same IP or not. But before that, let me go to the service first. kubectl get service, and here in the service we have the nginx service, and this is the port on which it is running at the moment. We can also go with -o wide option if we need more information related to the service. So here it is. It is also telling me the selector information. Now let's see with the endpoint. kubectl get endpoint, and after that we need to give the name, and the name is this service. Now here, if you see here in the endpoint for this service, we have the endpoint this, which is registered. And if we look at this endpoint, the IP address is for this this pod, sorry. Correct? Now let me do one thing. Let me go to the deployment file one more time, and let me change the replica set to 3. Let me deploy this thing. kubectl apply -f deployment.yaml. It's done. Let me look for the kubectl get pod. Now we have 2 of the pod in creating state. Let me refresh. Okay, one is in running, one still creating. Let's wait for it to create. Yes, now all the 3 pods are in running. And if you look at the IP is this, this, and this. Let me go to the endpoint. So here is the endpoint. And if you see, we have these 3 IP address. This is the work of the Kube proxy to update this endpoint. And if you look at this, 68, 67, and 80. So same. Sorry, 66, 67, and 68. 67, 66, and 68. Let me do one thing. Let me delete this thing. Or nano deployment. Let me change the replica to 1 again. Applied the changes. kubectl get pod. Okay. Now we can see only one pod in this is in the running state. Let me go with -o wide option. And let's check for the endpoint. See, we have only one IP address listed here, the same IP. So this is the work of the Kube proxy to update the endpoints information.